Singapore Choice സമർപ്പിക്കുന്നത് QBB Pure Ghee. Superior taste in so many ways. Powered by House Brand. Variety is the spices of life. Co-sponsored by Karthika Stores. Complete range of food products since 1989.
ഏഷ്യാനെറ്റിന്റെ എല്ലാ പ്രിയപ്പെട്ട പ്രേക്ഷകർക്കും സിംഗപ്പൂർ ചോയ്സിലേക്ക് സ്വാഗതം. മനോഹരമായ സെഗ്മെന്റ്സ് ആണ് ഇന്ന് സിംഗപ്പൂർ ചോയ്സിൽ. ഓരോന്നോരോന്നായി കാണാം. ഞാനിപ്പോൾ നിൽക്കുന്നത് ആർട്ട് സയൻസ് മ്യൂസിയത്തിലാണ്. ഈ മ്യൂസിയത്തിനെ കുറിച്ച് പറയുകയാണെങ്കിൽ ഇതിൻ്റെ സ്ട്രക്ചറിൽ തന്നെ അത് തുടങ്ങും. ഒരു ലോട്ടസ് സ്ട്രക്ചറാണ്. വളരെയധികം വെറൈറ്റി ആയിട്ടുള്ള ഡിഫറെൻ്റ് ആയിട്ടുള്ള ഒരു സ്ട്രക്ചറാണ് ഈ ആർട്ട് സയൻസ് മ്യൂസിയത്തിൻ്റെ. മാത്രമല്ല ഇവിടെ നമ്മൾ വന്നപ്പോൾ ഇവിടെ ഒരു എക്സിബിഷൻ നടക്കുന്നുണ്ട്. എന്താണെന്ന് വെച്ചാൽ ദ സ്ട്രേറ്റ് ടൈംസ് എന്ന് പറഞ്ഞൊരു ന്യൂസ് പേപ്പർ, അത് 1845 അത് തുടങ്ങിയത്. ആ ന്യൂസ് പേപ്പറിന് ഇപ്പം 170th ഇയർ ആണ്. ഇപ്പം 170 വർഷമായി ആ ന്യൂസ് പേപ്പർ കണ്ടിന്യൂ ചെയ്തു വരുന്നു. പണ്ട് മുതൽ ഈ ന്യൂസ് പേപ്പർ എങ്ങനെയായിരുന്നു, അതിൽ എന്തെല്ലാം കാര്യങ്ങളുണ്ട്, ബിസിനസ്, എഡിറ്റോറിയൽ, അങ്ങനെ ഒരുപാട് കാര്യങ്ങളുണ്ടല്ലോ. അതെല്ലാം പണ്ട് മുതൽ ഇപ്പോൾ എന്തൊക്കെയാണ് കറണ്ട് സ്റ്റേറ്റസ്, കറണ്ട് ഇഷ്യൂസ് എന്തൊക്കെയാണ്, അതെല്ലാം കൂടി ചേർത്ത് ഒരു എക്സിബിഷനാണ് നമ്മൾ കാണാൻ പോകുന്നത്. ഇപ്പം നമ്മുടെ കൂടെയുള്ളത് ആർട്ട് സയൻസ് മ്യൂസിയത്തിൻ്റെ എക്സിക്യൂട്ടീവ് ഡയറക്ടർ ഓന ആണ്. നമുക്ക് കൂടുതൽ കാര്യങ്ങൾ, കൂടുതൽ ഇൻഫർമേഷൻസ് ഈ ഒരു എക്സിബിഷൻ നടക്കുന്നതിനെ കുറിച്ച് ചോദിച്ചറിയാം. ഹായ് മാം.
Hello.
Yeah. Ma'am, first of all, can you talk a little background of this Art Science Museum?
Yes, certainly. So Art Science Museum is the museum that explores the interconnection point between art, science, culture and technology. And we're really here to show the place where art and science meet. So we do everything from bringing in exhibitions by leading artists such as Salvador Dali, Vincent van Gogh and Leonardo da Vinci, as well as exhibitions which explore scientific topics such as marine biology, which would be exemplified by the exhibition we've got on right now called The Deep.
ഇവിടെ ഒത്തിരി കാര്യങ്ങൾ നമുക്ക് കാണാനുണ്ട്. അതെല്ലാം കാണിച്ചു തരാനും പറഞ്ഞു തരാനും നമുക്ക് ഓണ എവിടെയുണ്ട് നമുക്ക് ചോദിക്കാം. ഓണ, സോ can you talk about a little background of this exhibition?
Absolutely. So we're standing here at the opening gallery of Singapore Stories. And this is a very special exhibition that we've brought in, which celebrates both the 50th anniversary of Singapore as an independent nation and the 170th anniversary of the Straits Times, which is Singapore's most well-known newspaper. So here we're looking at 170 years of Singapore's history through the lens of the Straits Times. And then we're looking 50 years ahead into the future about how Singapore might evolve over the next 50 years.
Okay. So we can start from here?
Yes, absolutely. Let's walk through the exhibition.
Okay.
So in this gallery here that we're looking at every single front page of the Straits Times since it was published. So we're cycling through all of the front pages from the very first edition way back 170 years ago to the most recent editions. And these screens basically cycle through the newspaper at different speeds.
ഇത് ഇവർ കാണിക്കുന്നത് സ്ട്രേറ്റ് ടൈംസ് തുടങ്ങിയ സമയത്ത് തുടങ്ങിയിട്ടുള്ള പേജസ് ആണ്. ഓരോന്നിലും ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കുന്നത്. അപ്പോൾ നമുക്ക് കണ്ടാൽ മനസ്സിലാവും അന്നത്തെ കാലത്ത് എങ്ങനെയായിട്ടുണ്ടാവും അവരുടെ പേജസ്, അവരുടെ ഓരോരോ പേജാണ് ഈ കാണിക്കുന്നത്. സോ വിൽ ഗോ ടു നെക്സ്റ്റ് സെക്ഷൻ.
Absolutely. Here we're looking at a timeline from 1845 right up to the present moment that sets out the whole 170-year history of the Straits Times from the very first edition on July the 15th, 1845, right up to the most recent edition on July the 15th, 2015. And we've got these incredibly fascinating and important historical artifacts here, including this logbook here, which is an incredibly special logbook for us in Singapore because it shows the diary of one of the photographers from the Straits Times, and it includes this very significant entry here. You can see the third entry, the wedding reception of Mr. and Mrs. Lee Kuan Yew. So this is a photographer that then went to take that photograph there of Mr. and Mrs. Lee when they got married. So for the people of Singapore, this is a very significant kind of artifact.
Newspaper newspaper pages are pinning either ആ സമയത്തുള്ള ഫോട്ടോഗ്രാഫർ എഴുതി വെക്കും നമ്മൾ ഓരോരോ ഫോട്ടോ എടുക്കുന്നതും അതെല്ലാം എഴുതി വെക്കും ഇതിൽ നേരെ നമുക്ക് ഇതിലിങ്ങനെ സൂം ചെയ്താൽ കാണാൻ പറ്റും വെഡിങ് റിസപ്ഷൻ ഓഫ് ആ ലീ ക്വാൻ യു ഇവിടുത്തെ പ്രൈം മിനിസ്റ്റർ ആയിരുന്നു അദ്ദേഹത്തിന്റെ കല്യാണത്തിന്റെ ഫോട്ടോ എടുത്തത് എഴുതി വെച്ചിരിക്കുകയാണ് അപ്പം അത് ഭയങ്കര ഒരു കാണുമ്പോൾ ഒരു സർപ്രൈസ് ആയിട്ട് നമുക്ക് കാണാൻ പറ്റിയതാണ് ഭയങ്കര ഓപ്പർച്യൂണിറ്റിയാണ് ഇത് കാണാൻ സാധിച്ചതിൽ എനിക്ക് വളരെയധികം സന്തോഷമുണ്ട് അതിൻ്റെ എല്ലാ ഡീറ്റെയിൽസും ഇവിടെ ഉണ്ട് അതിൻ്റെ ഫോട്ടോ ഉണ്ട് ഇവിടെ
So the way that we've laid out this exhibition is mirroring the actual sections of the Straits Times newspaper. So each section corresponds to a section in the newspaper. So in the Straits Times, we start with the business section. So that's where we start the exhibition. And here we talk about Singapore's history through the lens of business, from its early days as a trading port all the way up to the development of container shipping. And here, two important features of the exhibition. This is the front page of the very first edition of the Straits Times, and here on the iPad you can read the entire newspaper. So this is the original edition right here. And if we carry on through to the back galleries, we've just installed over the last few days this priceless artifact here. This is the very first edition of the Straits Times here. So this is on loan from the National Library of Singapore, and so this is the edition of the Straits Times that was published, on the 15th of July 1845, the very first edition.
Okay. ഇതെങ്ങനെയാ പോകുന്ന വെച്ചാൽ ഓരോ ന്യൂസ് പേപ്പറിലും നമുക്ക് ഓരോരോ ഇതിപ്പം ബിസിനസ് എഡിറ്റോറിയൽ അങ്ങനെ ഓരോന്നും ഉണ്ടാവില്ലേ അപ്പോൾ ഈ ഒരു സെക്ഷൻ ബിസിനസ് സെക്ഷനാണ് ഇവിടെ ആ സമയത്ത് പണ്ട് കാലത്തുള്ള ഓരോ ട്രേഡും അങ്ങനത്തെ കുറേ ബിസിനസ് സംബന്ധിച്ചിട്ടുള്ള എല്ലാ തരം ഇൻഫർമേഷൻസും ഇവിടെ ഓരോന്നും എക്സിബിറ്റ് ചെയ്തിട്ടുണ്ട് അതാണ് ഇപ്പം നമുക്ക് നല്ല ബ്യൂട്ടിഫുൾ ആയിട്ട് നമുക്ക് എക്സ്പ്ലെയിൻ ചെയ്തു തന്നത് ആർട്ട് സയൻസ് മ്യൂസിയത്തിൻ്റെ വിശേഷങ്ങൾ ഇവിടെ തീർന്നില്ല അടുത്ത ആഴ്ച വീണ്ടും
QBB Pure Ghee for cooking, baking and barbecue. Superior taste in so many ways. QBB Pure Ghee.
Chicken curry is just 1, 2, 3 steps.
ഹൗസ് ബ്രാൻഡ് കറി പൗഡർ തനത് സ്വാദിന്റെ സംതൃപ്തി അരനൂറ്റാണ്ടിനും മേലെ.
എന്റെ ഒരു കൂട്ടുകാരിയാ കാർത്തിക സ്റ്റോഴ്സിനെ പറ്റി പറഞ്ഞ് വന്നു നോക്കി അപ്പോഴല്ലേ പൊടിപൂരം ഉപ്പ് തൊട്ട് കർപ്പൂരം വരെ ഇവിടെയുണ്ട് ഇപ്പതേ ഇവർ ഓർഡർ അനുസരിച്ച സാധനങ്ങൾ വീട്ടിലെത്തിച്ചു കൊടുക്കുകയും ചെയ്യും നമ്മുടെ നാടൻ സാധനങ്ങൾ വേണോ കാർത്തികയിലേക്ക് വന്നോളൂ ഇനിയിപ്പോൾ സെരാൻകുൺ വരാൻ ബുദ്ധിമുട്ടുള്ളവർക്ക് ഈശ്വൻ ഭാഗത്ത് വിനോദ് സ്റ്റോഴ്സിലും സാധനങ്ങൾ ലഭിക്കും കാർത്തിക എന്റർപ്രൈസസ് പ്രൈവറ്റ് ലിമിറ്റഡ് 34 Buffalo Road, Singapore 219796. Phone 62977533.
Singapore University of Technology and Design. PhD program in Engineering Product Development. Singapore University of Technology and Design. A better world by design.
At Om Vedic, indulge in authentic Ayurvedic relaxing massages with proficient Ayurvedic physicians. Om Vedic successfully manages sinusitis, migraine, arthritis, skin and stomach disorders, fertility problems, and more. Om Vedic Heritage Center offers women's health and beauty, astrological consultations, and free meditation. Om Vedic, Singapore's leading holistic wellness center.
In a fast-paced life that we live in, I need a one-stop shop that pampers my every need because I have an image to keep.
At Emerald Beauties, we care because your image is ours.
Kerala's first international hospital from Singapore. അമ്മ എന്ന സ്വപ്നം കുഞ്ഞെന്ന യാഥാർത്ഥ്യത്തിലൂടെ obstetrics and gynecology, reproductive medicine, gynecology, neonatology, cosmetic surgery തുടങ്ങിയ സ്ത്രീകൾക്കും കുട്ടികൾക്കുമായി അതിനൂതന ചികിത്സാ സൗകര്യങ്ങളോടെ സിംഗപ്പൂരിൽ നിന്നും കിൻഡറിന്റെ അന്താരാഷ്ട്ര ഹോസ്പിറ്റൽ ചേർത്തലയിൽ. Kinder Life. Women's Hospital and Fertility Center, India, Singapore, Indonesia, Sri Lanka. Call 0478 283 0000.
ഞാനിപ്പോൾ നിൽക്കുന്നത് SUTD മുന്നിലാണ്. SUTD എന്ന് വെച്ചാൽ സിംഗപ്പൂർ യൂണിവേഴ്സിറ്റി ഓഫ് ടെക്നോളജി ആൻഡ് ഡിസൈൻ.
Today I'm going to show you what research we work on. We work on materials. So we use a simple process called electrospinning. And in electrospinning we use a polymer material. Here we dissolve the polymer in a solvent. We prepare this solution and then we use this solution for electrospinning. And here we use stimulus responsive materials that can respond to temperature, and we can control its wettability based on the temperature. Here we use electrospinning. It's a process where you apply a high voltage to a polymer solution, and then the polymer ejects out from the needle in the form of fibers. These fibers can be in few microns to few nanometers in diameter. The fibers that we prepare are about 200 to 300 nanometers in diameter. It's about 1,000th time the size of a human hair. So this is the material that we obtained from after electrospinning. This is a membrane made of nanofibers. Each fiber is about 200 to 300 nanometers in diameter. So this is the material that we obtained after electrospinning. It's a membrane made out of nanofibers, and here what you see is the sample under the microscope. As you can see, each fiber is about few hundred nanometers in diameter, the size of the fibers. And we use this material for stimulus responsive applications. So when we drop a water on this material at room temperature, the water is absorbed by the material. But when we heat the material, let's say at 30 degrees or 40 degrees Celsius, this material is hydrophobic, so the water is repelled by the material. So here we have our material which is placed in this temperature chamber. This temperature chamber is set at 40 degrees Celsius, and we drop a water drop on the sample surface and measure the contact angle made by the liquid water drop. If the water drop makes an angle greater than 150, we call it super hydrophobic material. And if it is greater than 90 degrees, it is considered as a hydrophobic material. So for our materials, we see that the contact angle is about 130 degrees. So this is a hydrophobic material which can be used for anti-reflective coatings, such as on your camera lens, for example. The same material, when we use it at room temperature, the water quickly absorbs within the material, so it becomes a hydrophilic material, and this can be used for anti-fogging applications. So this is the same material, and when we put a water drop at room temperature, the material absorbs water immediately. Within few seconds, the water spreads over the sample immediately. So this is considered as a hydrophilic material, and this can be used for anti-fogging applications.
Hi sir.
Hi.
You've already shown the demo of your research, so can you talk more on that?
Sure. So I work on materials, more specifically stimulus responsive materials, and I use a process called electrospinning to prepare the polymer fibers. So this process prepares polymer fibers in the range of few nanometers to few microns in diameter, and we use this for stimulus responsive applications. So currently we are working on materials that can switch its wettability when temperature is applied.
Your research focus on the development of functional surface such as self-cleaning surface. So can you tell more on that?
Sure. So this material, the switchable materials or temperature sensitive materials are also called as functional materials because when temperature is applied, this material becomes super hydrophobic, meaning that it repels water. And when at room temperature like 23 degrees Celsius, the material is hydrophilic, so it absorbs all the water. And this can be used for self-cleaning applications.
Can the size of the fibers can controlled?
Yes, the size of the fibers can be controlled by changing the electrospinning processes, such as voltage. If I reduce the voltage, the fiber size can be varied, and also if I increase the flow rate within the electrospinning, the fiber size can be increased.
Okay. How small can be the size of the fibers be?
So people have successfully demonstrated that they can obtain 50 nanometers diameter fibers. In our lab, we are about 100 to 150 nanometer is commonly obtained.
What are the other possible application of this research?
So this can be used for tissue engineering applications. It can be used for cell growth, cell proliferation applications, and there are various other applications. It can be used for just self-cleaning applications. It can be used for breathable fabrics, which is commonly used now, and there are various applications.
I'm Mohan Rajesh, lecturer at Engineering Product Development pillar. We know that many insects such as the spider is capable of navigating in very adverse, hostile, dynamic environments without being noticed, where even engineering systems would fail. So here at SUTD, we are looking at, in my group, we are looking at extracting biological principles to exactly address these issues that we see with artificial systems, so that the performance of this robotic system could be extended and address needs in a variety of applications, such as urban reconnaissance, surveillance, search, and security. So what you see here is our robot Scorpio. So it mimics the characteristics, the locomotion and autonomous characteristics of Reichenbergi, a class of spider found in the deserts of Morocco. So this Reichenbergi, on top of every other spider, it crawls and then it rolls and climbs walls. So rolling is a very unique kind of locomotion found in this creature, which enables it to escape from predators in desert slopes. So it uses a kind of flick-flap somersault motion to roll. Taking it as an inspiration, we are now working on a new kind of novel robotic platform for the first time, where we mimic the gaits of Reichenbergi spider. We initially started with a platform that was about 30 centimeters in diameter in its rolling form, as you see here while it rolls. And through optimizing various parameters like the fabrication process, the actuators, the controller that we use for its artificial intelligence and so on, we could minimize the size of this platform from 30 centimeters here to that of 14 centimeters here. This is needed for a security mission because we want these robots to be hidden from any hostile agents. At the same time, we want a high level of computation and artificial intelligence capability. To just introduce, the platform currently has a number of gates. So this is the third generation in the class of Scorpio robots. It is capable of performing gaits such as moving forward, rolling, crawling. As you can see, it's now starting to crawl. So it's crawling forward, now backward. It turns, and it is capable of all other basic gaits that are needed to navigation in urban reconnaissance mission. So now it's rolling. It's capable of transforming at will from crawling to rolling modes. So the platform now is also capable of recovering. So you could see it's rolling now. At any point in time, so let's say if as you see here, if the platform falls over, it can recover by itself. A recovery gate is very much needed in any urban reconnaissance mission, because if the robot has fallen over from an accident, it has to be able to recover by itself to a known state so that it can continue with the process. In terms of autonomy, security robots like Scorpio should be able to assess the terrain in which it's traversing and make an appropriate decision on what type of locomotion is going to use, rolling or crawling. For example, for Scorpio, it's much easier to roll down a staircase or a slope as compared to crawling down, which is going to take a lot more energy and a lot more stress on its motors and the parts and the fabrication parts. Also, when it comes to navigating through an obstacle-filled terrain, let's say pebbles, it's going to be very difficult for it to roll. Crawling is going to be easier. And to make that decision autonomous, the platform is equipped with a camera and inertial sensors, so it uses a mixture of color, texture, and orientation information to make decisions, real-time decisions, on what kind of form or what kind of morphology I'm going to take, and also what kind of locomotion mode I'm going to adopt to navigate this terrain. So currently we have very good success, and we are planning to build on these initial positive results and to, of course, improve the existing system to make it smaller and also to be more intelligent so that it could be ready for real world deployment and saving security person lives in the future.
തിരുമല നെയ് ശർക്കര പായസത്തിന് സ്ട്രോങ് സപ്പോർട്ട്, നെയ്ദോശയ്ക്ക് സൂപ്പർ സപ്പോർട്ട്, ഗുലാബ് ജാമിന് ക്ലോസ് ഫ്രണ്ട്, വീട്ടിലും വിരുന്നിലും ഏറ്റവും അടുത്ത സുഹൃത്ത് തിരുമല നെയ്.
തിരുമല നെയ്.
Chicken curry is just 1, 2, 3 steps.
ഹൗസ് ബ്രാൻഡ് കറി പൗഡർ തനത് സ്വാദിന്റെ സംതൃപ്തി അരനൂറ്റാണ്ടിന് മേലെ.
In a fast-paced life that we live in, I need a one-stop shop that pampers my every need because I have an image to keep.
At Emerald Beauties, we care because your image is ours.
Hi, I am Assistant Professor Feng Xiaohui. I am one of the faculty members here at the Engineering Product Development Pillar at SUTD. So today I would like to talk about one of my PhD projects here that we have been working on, which is the localization of a nasogastric tube. So what is a nasogastric tube? A nasogastric tube is something like this here. It's just a plastic tube, and the process of this is we need to actually insert this into patients through the nasal cavity, which is the nose. And the target is actually to place this all the way down to the stomach. So this is normally done blind, means the nurse or the doctor will actually put it through the nose, and hopefully most of the time by experience they wanted to put it in the stomach. The bad thing that is because is this done blind, we don't know where it goes. Right? It can go into the stomach, not go to the stomach, but go into the lungs, which can be very dangerous. So what we have here is to find a means of ways to track it as we are inserting down the tube. So the tube is, what we did is we make it almost unchanged. What we did is we inserted a small magnet here, and here I can show you a model of the body. Right? So this is the nasogastric tube. We insert it through the nasal cavity. Target is at the stomach. Right? The main cause of error is when it goes into the windpipe, which is your lungs. We don't want that. Right? So we want it to go through the esophagus into the stomach. So what we did is we designed a special system of sensors here that reads the magnetic field and converts the magnetic field measurements into position. And from there, I can show you on the screen, once we read it, we can localize it in space. Right? So you can see this is the screen of where the magnet is, and depending on where I put it in, right, you can see that it updates right, where it is in the body. So we know immediately right, where the error is, whether the tube is going into the lungs or not, or going into the correct location. So this requires a lot of engineering. First, you need to understand magnetic fields. You also need to understand how the applications of sensors, right, how to improve the accuracy, algorithms, sensing positions, as well as the approach to reduce errors in this.
I'm Javier G. Fernandez. I'm a professor at SUTD. I'm from Spain, and I work in bio-inspired materials. So what we basically do is that we take materials that are coming from nature, and that also we take the design from nature. So we combine both of those components to make artificial stuff. We do like plastic wear, we do even prostheses for surgery. So, and all of that is based in components and designs from nature. So the good thing from this is like we are covering two very broad areas. One is manufacturing, sustainable manufacturing, and then the other one is medical engineering. So we are making really big advances in both of those areas. First, like providing with sustainable materials for manufacturing, and also providing with biocompatible materials for medicine. So those are materials that basically you will put in your body and they will not have an immune reaction. Your body will understand how they are, and they will transform with your body. They will be assimilated in your body. So as part of this research, we invented like 2 years ago a material called the Shrilk. So Shrilk was a material made of, or is a material made of a component in the shrimp cells called chitin, and then a component from the silkworm, from the silk, that is called fibrin. So what we basically discover, if you take like these two components and you reproduce the natural design and molecular scale of the skin of the insects, that is where you can find also these two components, you can get materials that are extraordinarily strong. And what I mean by extraordinarily strong is that materials that are in the range of the metals, but actually they are half of the weight of the metals. So this is, again, all these materials are biocompatible and they are sustainable. So you can throw them to the ground and they will degrade and then return to the ecological cycle from the ground. So we demonstrate, for example, that you can take these materials and then you can use them to grow plants in them. So basically, like the problem that we were generating with plastics now has transformed, that you have materials that when you throw them to the ground, they actually produce a positive impact on the environment. So what we basically do is like we take this material, this is called chitosan. So we get chitosan from the shrimp cells, and in particular in this area of the world, so we have Vietnam produce a lot of shrimp cells, India produce a lot of shrimp cells. So basically, actually this chitosan is coming from India. So what we do is like we take those shrimp cells and then we remove all the components except the one that I'm interested in, that is this one called chitin. So with this material, we are actually able to dissolve it. So we put in a solution where the molecules are able to flow. So from there, what we do is like we take them and then we reproduce how those molecules they align in nature. So we take these materials and then what we do is like we reproduce that molecular alignment, how these materials organize in nature to make the stuff that we want. So in this case, for example, we do like plastic work. So we do these kind of things. This looks like regular plastic cups. So the difference is that because we are using a natural material that we haven't modified. So the only thing that we have done is use this material exactly in the same way as nature uses it, from a molecular scale. So we arrange this material exactly in the same way as nature does, so we are actually able to reproduce the amazing properties of natural materials from the molecular scale. So doing that, we can conform the shapes that we want and also have these good mechanical properties, these kind of like tough and strong materials.
ഇന്നത്തെ എപ്പിസോഡ് എങ്ങനെ ഉണ്ടായിരുന്നു? അടിപൊളിയായിരുന്നില്ലേ? ഇതിലും അടിപൊളിയായിട്ടുള്ള എപ്പിസോഡായിട്ട് ഞാൻ അടുത്ത ആഴ്ച വീണ്ടും വരും. അതുവരെ സ്റ്റേ ട്യൂൺ, ടേക്ക് കെയർ, ബൈ.